Hello, I'm Lima Alpha 6 November Charlie Alpha. In this video I will try to build a power supply for this old radio.
I received this package from my good friend Hummer Hoymark. It should contain a power supply for old tube radios. Several of these German WW2 radios require 2-volt filament voltage and 90-volt anode voltage. It is well packed. Oh, this one looks nice. It was purchased from Amazon. The voltage input is 12 volts, which is good. Filament voltage is good, but anode voltage is a little too high. Now I want to measure the filament voltage. I turn down the voltage setting. Very good, it reaches 2 volts, which is the correct voltage. I have connected a load resistor. The voltage is completely stable even with a 2 amp load. And now I want to measure the anode output. I must screw the wrong way. There it stopped at 140 volts. It's too much. I have to go in and change the circuit a bit to get 90 volts. Here we see that the wiring diagram is divided into 2 parts, high and low voltage. I have to change the value of this feedback resistor from 1 megaohm to 0.5 megaohm. I am soldering in a 1 megaohm resistor in parallel with the one that is there. Incredibly small components. I attach it with the soldering iron. Then I solder it in place with tin solder. Yes, now the voltage is lower. Another and simpler way is to have a drop resistor and capacitor on the output. Then it is ready for testing. Now I want to show how I know which pins should have the different voltages. I use an ohm instrument. Connect the negative terminal to GND on the radio. One pin shows 0 ohms. This is the negative filament terminal. This is also the ground terminal. Now I will find the positive filament pin. This pin is connected to the power switch and shows 1 ohm when the power is on. Now I want to find the anode power negative pin. This pin shows approximately 200 ohms to ground. Other types of radio will show slightly different values. The last pin, which is the anode positive terminal. It has quite high resistance. Then the pins are found without documentation. Lab power is connected and the signal generator is set to 3,880 kilohertz with 10 microvolt output. The scale shows exactly right 50. After 84 years, it is absolutely fantastic. I use 2 separate powers, no common ground connection. The voltage on the anode negative pin is negative 1.85 volts. This is the grid bias for the entire radio. But what happens if we connect the 2 negative power cables together? The anode current increases only slightly. The power from Amazon has common ground. The radio still works great. The current in the tubs is not too large either. Goes down to 1 microvolt. Works well. A 1.5 volt battery can be used to generate the negative bias. Remember that it will then take approximately 8 milliamps of current from the battery. Works well with 0.2 microvolts too. The conclusion is that it works with common ground. Possibly that the large signal characteristics are getting worse. I connect the antenna.
I've just cleared and went to the little boy's room to sat back down. I was just tuning round and then basically. Ja, abgelaufen, ne? Der hat schon die Karkasse gelöst. Dann haben wir dann da irgendwo im Ort uns 9 Reifen besorgt, ne? Und der Vermieter hat das natürlich auch.
Common ground also works well with the antenna. Now I want to try the Amazon power for the first time. I am sending in a signal of 1 microvolt at 50 on the scale. As we hear, there is a constant high-frequency beeping sound there, and then there is noise on some frequencies. That's the power we hear. Here we see the 2 volts, 0.6 volt, ripple at 15 kilohertz. On the lower bands, we hear this ripple very well. I connect a 1000 microfarad capacitor. The ripple disappears completely. I have mounted the Amazon Power on a circuit board copper plate. Here I have connected the power to a Torn EB. A spectrum analyzer is connected to 90 volts. This is the noise from the power unloaded. And this is what it looks like under load. We clearly hear the noise in the receiver. We cannot use this. I need to design a filter. This is the filter I have found that works well, both on 2 volt, 90 volt, negative bias, and 12 volt input. Remember that the capacitors must withstand the voltage. I will now show how well the filter works with different capacitors. All are at 100 nanofarad. I normalize the instrument. I measure from 1 to 30 megahertz. The curve vertically is 100 decibels. I measure 100 nanofarad, 250 volt MKT capacitors. They work very well. Down 67 decibels at 3.7 megahertz, slightly less at higher frequencies. Now I want to test 100 nanofarad ceramic SMD capacitors. These can only withstand 25 volts, so they cannot be used at the anode voltage. Fantastic result. Down 100 decibels at 3.7 megahertz. Finally, I will test out the 33 nanofarad 1000 volt ceramic. Also works very well. 100 decibels down at 3.7 megahertz. Now everything is mounted in the box. All filters are in place. The spectrum analyzer is connected to 90 volts. Here, we see the background noise. This is the idle noise from the power. And this is the noise under load. Very good. And it gets even better with the lid on. And now I will test the power. I send a microvolt signal, 3,880 kilohertz. I have installed a voltmeter in the radio. Cables and holes were ready for this. We can read both voltages. We can hear the weak signal just fine. We cannot heard any noise signals. Works absolutely great. Now I want to power the torn.few.b1 lab power supplies 2 volts and 130 volts. A battery delivers negative 4.5 volts. Here is the connection. I am trying to remove negative grid voltage. It doesn't work. A battery works fine. No current flows. I have chosen to generate the negative bias voltage from the power supply. I rectify the square pulses from the 2-volt part. The desired voltage is set on R2. Here the components are mounted in the box. The different radios have slightly different pinouts, so I have mounted a switch. Now the power is finished, and I'm going out to test it. The receiver works fine without power noise.
Come up with something that got the best of all the previous
I will go out and test the power in the field, and I will program the transmitter's frequency. I loosen frequency setting number 1. I will use 3,660 kilohertz. Uses a frequency counter to find the correct frequency. I fix the frequency setting. This was also done during the war before going on a mission. Exact frequency is important. I have now taken the trip out in -8 degrees Celsius. Nice test of the power. Here is the power. I connect 12 volts to the power. I want to use a wire antenna. I use a phone for audio in and out of the radio. This is the ground plane. I will try to throw the antenna up into the trees. I use a rock to throw up the antenna. The power works great in the cold. I'm tuning the antenna.
Lima Alpha 1 Tango Kilo Alpha. Lima Alpha 1 Tango Kilo Alpha. Dette er Lima Alpha 6 November Charlie Alpha. Over.
du veldig svak. Jeg kan nesten ikke lese det.
Ja, det er mottatt. Kan du gi meg en rapport? Hva slags styrke kom jeg inn med hos deg, og leselighet over?
Ja, du er 3 og 3 her hos meg, Helge. Eller 6 eller en DK.
Ja, det er mottatt. Du er sterk og klar her. Sterk og klar. Flotte signaler.
I have moved to a new position. The field phone is connected.
Lima Alpha 5, X-ray India Alpha. This is Lima Alpha 6, November Charlie Alpha, over.
Lima Alpha 6, November Charlie Alpha, Lima Alpha 5, X-ray India Alpha, over.
Okay, this is Lima Alpha 6, November Charlie Alpha. Please give me a report, over.
Yeah, you are 5 and 9 plus 10. 5 and 9 plus 10, over.
Thank you very much. 73, Lima Alpha 5, X-ray India Alpha. This is Lima Alpha 6, November Charlie Alpha, over.
Lima Alpha 5, X-ray India Alpha, 73.
Thank you for watching my video. If you like it, please press the subscribe button and please write a comment below. Thank you.
Camera. Marianne Mearsby. Thanks to LA1TKA and LA5XIA.